Okay, students. So in this particular video, I welcome you all for JEE Maths Mantra YouTube channel. So, and in this particular video, I am going to talk or I am going to take one concept of mathematical induction, and I want to explain how this mathematical induction problems are going to be solved. And here I will also explain with what logic the mathematical induction problems are going to be solved. Okay, so in this mathematical induction chapter of class 11, they apply the logic of deductive mathematical reasoning or deductive reasoning, we say. What is the meaning of deductive reasoning? You just see. In deductive reasoning, we are going to have the statements. I will take the first statement as Pawan sir is in room 16. That means Pawan sir is in room 16. Okay. And the second statement is the persons who are all in room 16 are maths teachers or maths lecturers Okay, so then what it conclude? Pawan sir is what you can conclude about these two statements? Pawan sir is maths lecturer. Okay, so like this you can conclude the statement, that is the third statement, and this is called deductive reasoning. Okay, so this method is going to be used in mathematical induction chapter of class 11. Okay, so how to simplify or how to solve the problems of mathematical induction chapter, we shall see by solving the examples one by one. Okay, so I will take the examples one by one of your class 11, that is mathematical induction chapter, and you just go through that, and we shall see how to solve those problems. Here the example one is example 1. For all n greater than or equal to 1, prove that 1 square plus 2 square plus 3 square plus so on to plus n square is equal to n into n plus 1 into 2n plus 1 divided by 6. Okay, so here the logic is deductive reasoning, and in the deductive reasoning, first I will take n equal to 1, and in the second I will take n equal to k, and in the third I will take n equal to k plus 1, and I simplify this. Okay, so if it is true for n equal to 1, it is true for n equal to k, then it is going to be true for n equal to k plus 1, hence it is true for all n. Clear? Okay, first put n equal to 1. So what you are going to get on the LHS, you just see, you will get 1 square, because n value is 1. If I put n value as 1, it will be 1 square. 1 square is 1, no problem. See on the RHS, 1 into 1 plus 1 into 2 into 1 plus 1 divided by 6. So that is 6 by 6 is nothing but again 1. So 1 square is equal to 1. Okay. So then it is true for n equal to 1. Next, put n equal to k. Put n equal to k. See what happens. 1 square plus 2 square plus 3 square plus so on to plus k square equal to k into k plus 1 into 2k plus 1 divided by 6. Okay. So now I will go for k plus 1. I will go for k plus 1. If you want to go for k plus 1, you just add k plus 1 on both sides. If you want to go for n equal to k plus 1, you just add k plus 1 on both sides. So what it will be? 1 square plus 2 square plus 3 square plus so on to plus k square plus, see, you have to put n equal to k plus 1. If I put n equal to k plus 1, it will be k plus 1 whole square. That means I am adding k plus 1 on both sides. So k plus 1, 2k plus 1 and add k plus 1 whole square on the both side. Adding k plus 1 whole square on the both side, because if I take n equal to k plus 1, is going to be nothing but with the step of adding k plus 1 on both sides. This will be divided by 6 and here I am going to add k plus 1 whole square. Okay. So my dear students, now this term, see, now this term has to be solved in the form of n into n plus 1 into 2n plus 1 divided by 6. Here in the place of n, you must get k plus 1. In the place of n, you must get k plus 1. In the place of n, you must get k plus 1. Then the problem is over. Okay. So let us see this. That is, now we have to solve k into k plus 1 into 2k plus 1 divided by 6 plus k plus 1 whole square. K plus 1 whole square. So now I can simplify this as k into k plus 1, 2k plus 1 plus 6 times of k plus 1 whole square divided by. So now this will be k into k plus 1, 2k plus 1, and if you if you want to simplify this, take k plus 1 common. That will be very easy. So take k plus 1 common. If I take k plus 1 common, what you are going to get? Here the k is remaining, here the 2k plus 1 is remaining, plus k plus 1 it gone outside, so remaining with 6 times of k plus 1 divided by 6. Okay. So now you can just see that this is going to be k plus 1 into 2k square plus k. Here you have plus 6k. 6k plus k is 7k. This is going to be equal to 2k square plus 7k. 6 plus 1 is 6. Okay. So 2k square plus k plus 6k is 7k plus 6 divided by 6 you are going to get. So now 2k square plus 4k plus 3k plus 6. You have to simplify this by taking factors. 2k, k plus 2, take 3 common, k plus 2. So therefore 2k plus 3, k plus 2. Okay. How can you write k plus 2? You can write it as k plus 1 plus 1. How can you write 2 times of k plus 3? 2 times of k plus 1 plus 2, because 2 into k is 2k, 2 into 1 is 2 plus okay, here you write 1. Here you write 1. Okay. So if you write 1 here, 2 into k is 2k plus 2. 2 into 1 is 2. 2 plus 1 is 3. You are going to get 2k plus 3. Okay. So therefore, this is nothing but k plus 1. So k plus 2 can be written as k plus 1 plus 1. And the remaining term you can write it as 2k plus 1 plus 1 divided by 6. So now you see your answer, that is 1 square plus 2 square plus 3 square plus n square is equal to what? N into n plus 1 into 2n plus 1 divided by 6. In the place of n, you have k plus 1. In the place of n, you have k plus 1. In the place of n, you have k plus 1. Okay. So we can conclude that hence for all n greater than or equal to 1, we have 1 square plus 2 square plus 3 square plus so on to plus n square equal to n into n plus 1 into 2n plus 1 divided by 6. Okay, students. So like this, you have to simplify your mathematical induction problems. So now I will go for one more problem. That is example 2. That is example. Clear? So see the example 2, that is, can take example 2 as prove that 2 to the power of n is greater than n for all positive integers, n, for all positive integers n. Okay. So while solving, you just see what is the given function. 2 to the power of n is greater than n. So first put n is equal to 1. What you are going to get? 2 to the power of 1 is greater than 1. It is true. Next put n is equal to k. What you are going to get? 2 to the power of k is greater than k. Okay. So now you can go for the third step, that is k plus 1. That means I will multiply 2 on both sides. So if I multiply 2 on both sides, what I am going to get? See here, this is nothing but 2 to the power of k plus 1. Okay. Because we have to go for n is equal to k plus 1. That's why here n will be equal to k plus 1. That is greater than 2k means what? K plus k. Okay. So now what we need to prove? In the place of n, we need k plus 1. In the place of n, we need k plus 1. Therefore, you can just see always k plus k is going to be greater than k plus 1, because here you have k, which is always greater than 1. Okay. So k plus k is always going to be greater than k plus 1. It is always greater than k plus 1. Why? Because it is k plus k. Getting my point? So therefore, if you see this, I can write 2 to the power of k plus 1 is greater than k plus 1. 2 to the power of k plus 1 is greater than k plus 1. So hence it is true for n is equal to k plus 1. Therefore, we can conclude 2 to the power of n is greater than n for all positive integers n. Very simple logic, you just understand it. There, what you have to do while solving the problem? First you have to take n equal to 1. Next you have to take n equal to k. And in the next third step, you have to solve in the form of n equal to k plus 1. Okay. So that means in the place of n, you have to put k plus 1. And you have to prove that 2 to the power of k plus 1 is greater than k plus 1. Wherever you have n, there the term must be k plus 1. In that situation, the problem has to be converted. So that's why what I will do, for 2 to the power of k, I will multiply 2 on both side. Multiply 2 on both side. If you multiply 2 on both side, what will happen? 2 to the power of k into 2, 2k. So this will be 2 to the power of k plus 1. 2k can be written as k plus k. And we know that with the common sense, k plus k is always greater than k plus 1. K plus k is always greater than k plus 1. Clear? So therefore, from this relation, see this, from this relation, what I can write? I can write it as 2 to the power of k plus 1 is greater than k plus 1. Hence, it is true for n is equal to k plus 1. Clear? So please comment if you get any doubts. Please comment if you have any type of difficulties while solving the problems. If you understand, you share the videos for as much as your friends possible. At least share for minimum members so that all can get this knowledge. So quickly like and subscribe this. The next mathematical induction video, I will go with another 2 examples. Clear, students? Let us meet in the next session with mathematical induction with another more example.